There is a place in the ocean where light gives up, where oxygen thins to a whisper, where most animals slow or die. And yet, something moves, not hunting, not fleeing, just drifting, calmly, in a world that should not allow it. Its eyes are too large, its body too quiet. Its name sounds like a myth, but this creature is real, and nothing about it is normal. As we descend beneath the surface, past the sunlit blues, past the last flickers of green, we enter one of the strangest environments on Earth, the oxygen minimum zone. Here, oxygen levels drop so low that fish suffocate. Predators disappear. Life becomes slow, rare, and fragile. Yet this is where the vampire squid lives. Not at the bottom, not near the surface, but suspended in this invisible desert, where breathing itself is a problem. Scientists still don't fully understand how this zone formed so widely across the oceans. But somehow, the vampire squid didn't just survive here, it specialized. The vampire squid doesn't behave like a squid at all. It doesn't jet away from danger. It doesn't chase prey. It barely moves. Its metabolism is one of the slowest ever measured in a cephalopod, so low it's almost in hibernation. Its blood uses hemocyanin, a copper-based molecule that binds oxygen more efficiently than ours does in near-empty water. Think of it as breathing the last crumbs of air, and somehow making that enough. But this raises a larger question. If movement costs too much energy, how does it eat? The vampire squid does something almost no other squid does. It doesn't hunt. Instead, it waits. Two long, thread-like filaments extend from its body, delicate, almost invisible. They collect falling debris from above, dead plankton, fecal pellets, organic snow drifting down from distant surface life. Scientists call this marine snow, the leftovers of the ocean. The vampire squid rolls this debris into mucus-covered bundles and eats it slowly, patiently. It survives not by chasing life, but by feeding on what remains after life passes. What we've discovered only deepens the mystery. Why did evolution take such a dramatic turn here, away from speed, power, and aggression? In most squid, danger means one thing: run. The vampire squid can't afford that. So instead, it performs something else entirely. When threatened, it turns itself inside out. Its webbed arms rise and wrap around its body, exposing rows of soft, fleshy spikes. Not teeth, but a convincing illusion. Scientists call this the pineapple posture. No attack, no chase, just confusion. And if that fails, it releases clouds of glowing particles, bioluminescent mucus that hangs in the water like drifting embers. A slow-motion distraction in a lightless world. Yet scientists still don't know how often this defense is used, or what predators actually exist here to fear. Genetically, the vampire squid doesn't fully belong anywhere. It's not quite a squid, not quite an octopus. It's the last living member of an ancient lineage, closer to fossil cephalopods that lived over 300 million years ago. A survivor of multiple mass extinctions, while faster, stronger animals vanished. This one endured by becoming quieter, slower, almost invisible. Which raises an unsettling thought. How many other ancient strategies are still drifting below us, unnoticed? The vampire squid doesn't feel like a monster. It feels like a message, a reminder that life doesn't always win by conquering. Sometimes it survives by withdrawing, by adapting to emptiness itself. We've mapped more of Mars than this layer of our own oceans, and creatures like this still move through it, unwatched, unbothered, unexplained, and somewhere in that darkness evolution is still experimenting, quietly.